Being a potted plant owner can be incredibly rewarding. Indoor plants can improve air quality in homes, reduce stress, increase productivity, plus they're cute and fun to have around.
In recent years, social media has helped grow the popularity of indoor plants for aesthetic purposes. Unfortunately, many new plant owners today are falling into the same trap. Sure, you might think a mug, mason jar, or soup can would make a cute pot for planting. However, it is critical that any container you choose has proper drainage. To explain why, we first need to talk about how plants drink water.
Water moves from areas of high potential energy to low potential energy. Potential energy is the stored energy of an object. When we talk about potential energy forces involved with water, we usually just call it water potential.
One source of potential energy is caused by gravity. If you've ever spilled a glass of water, you've watched water travel from a higher water potential to a lower water potential. Another type of water potential is caused by pressure. Because most plants have to move water upwards against the pull of gravity, plants need to establish a water potential gradient that allows bulk flow of water upwards into the plant. This concept can be illustrated using the simplified analogy of a turkey baster. If you just point a turkey baster filled with water upwards, the water stays in the turkey baster. This is because the potential energy caused by gravity is equal to the pressure potential within the turkey baster. If you squeeze it, the water travels upwards because the potential energy from water pressure is able to overcome the potential energy from gravity.
So water will always travel from areas of higher water potential to lower water potential. Plants manipulate their water potential gradients to uptake water using three methods: osmosis, imbibition, and transpiration.
Osmosis is the diffusion of a substance across a membrane. Plant cells generally have a higher concentration of solutes internally than the solute concentration in their external environments. Another way of thinking about this is that the external environment generally has a higher concentration of H2O than the inside of the cell. If the cell wall and cell membrane were not present, solutes in the cell and water outside of the cell would diffuse until their distribution was equal. However, plant cell membranes are very particular with what they allow to pass through them. The water in the environment will move into the cell because it can pass through the cell wall and wants to travel from a higher concentration to a lower concentration. However, the cell wall does not allow for as much movement of the sugars and potassium salts inside the cell to diffuse into the environment. Through this process of osmosis, plants are able to uptake water into their cells without losing nutrients.
Imbibition is the process of charged water particles being attracted to charged particles in the plant. Many particles have charges, like miniature magnets. The shape of an H2O molecule results in one side being more positively charged than the other, so it is attracted to other polar molecules. The cellulose molecules within a plant's vascular system are also polar, so they help suck the water up into the plant. This is more prevalent in woody plants than it is in herbaceous plants, but it is why wood that is left in water will swell.
Transpiration might be the easiest to visualize because it is similar to the process of sweating in humans. We use the process of evaporating water to help keep ourselves cool, which is similar to how plants keep themselves cool. However, this is not the plant's only reason for transpiring. Leaves in a plant canopy contain tiny pores that can open and close called stomata. They use these for gas exchange, but also evaporating water. When water evaporates out of the plant and enters the atmosphere, it creates a miniature vacuum in the upper leaves of the plant. This process helps keep the water pressure gradient more negative at the top of the plant and pull water upwards against gravity.
So, the hotter the environment, the quicker the plant will evaporate water out of its stomata, and the more water it will pull upwards into the plant to help keep the plant cool. In fact, 90 to 95% of the water that plants take up is used in regulating temperature this way. So what does all of this have to do with drainage and houseplants? Well, one of the biggest problems is that when water can't drain out of the bottom of a pot, all of the solids that are in the water don't have anywhere to go when the plant has been watered.
If you've ever left a glass of water out and seen chalky white buildup in the glass, those are the solids I'm talking about. Most water from sinks contains minerals like sodium, calcium, and magnesium. In small quantities, these minerals can be good for plants. However, pots without drainage can accumulate heavy concentrations of these minerals and salts over time. Remember earlier when I said that plants use osmosis to pull water into their cells? Well, if the concentration of salts and solids becomes higher outside of the plant cells than inside of them, the same process will actually pull water out of the plant. Also, the processes of imbibition and transpiration can pull more of these minerals into the plant than it needs to survive. This can cause nutrient toxicities and even clog vascular tissues to the point where they can no longer uptake water.
Not to mention that plants need oxygen to reach their roots in order to survive. A pot with improper drainage can fill up with water, and this can suffocate the roots. It can also lead to fungal infections as well as other root diseases. Now, you may be thinking to yourself, but wait, I put a layer of gravel at the bottom of my cute little mason jar. Doesn't that give water and salt somewhere to drain? Unfortunately, this usually makes the problem much worse. To illustrate why, let's use the example of a household sponge.
The same water stickiness that's caused by water's polarity allows the sponge to hold water with what are known as capillary forces. The inside of the sponge has an enormous amount of surface area. The more surface area, the more area the water can stick to, and the stronger the capillary forces. Soil has these same capillary forces and will act in a similar way to the sponge. Because of this, the water will stay in the upper layer of the soil because it has more surface area than the gravel. In order for the water to flow into the gravel, the potting media needs to be completely saturated with water in order to overcome these capillary forces with the gravitational weight of the water. So, in order to get any of the salts to leach into the gravel layer, you would need to completely saturate the potting media. At that point, you've just completely flooded the pot and cut off the root's ability to breathe.
So it's safe to say that if you want to maintain a healthy houseplant for a long time, you really need to make sure that it's in a container that allows for leaching of salts as well as airflow to the roots. You can always try to use masonry, glass, or tile drill bits to add holes to other containers as well. But if you love your houseplant, recognize that its pot is its home, and think carefully about what kind of home would be best for its well-being.